So I'm Steven. I'm a solution architect at Epic Games. So that job title is kind of a mix between technical sales, technical support. I'm on the architecture team, so I help AEC customers use Unreal Engine or Twinmotion and the other Epic ecosystem products. And by association, that means I actually help a lot of people with their Cesium projects because it's basically industry standard for folks who are trying to do architectural or engineering-related visualizations. So my talk is titled Real-Time Fun with Cesium and Unreal. I think part of it is just Cesium is fun because you get instant gratification of, oh, the entire world is at my fingertips. But also, Unreal Engine is a game engine, so you can have lots of fun, creative opportunities there. Agenda for today. First, I'm going to start with some really basic industry examples of how people are just using Cesium day to day, so you see the more professional end results of it. Then I'm going to touch on scripting Unreal Engine, just taking the standard Cesium things you've been learning today and thinking about how to automate those a little bit better. Then the bulk of the presentation is actually going to focus on material effects, especially for the Google photorealistic tiles, really leveraging the hardcore artistry that has that Unreal Engine has that potential for. And then there's some extra credit stuff at the end. And this is not designed for you guys to walk through it with me step by step. I wanted to cover a lot of ground, and there's just a lot of advanced topics that would not be feasible to do in 30 minutes for all of you. And I know that for a lot of you, this is like your first time even opening Unreal Engine, or maybe you're just getting the hang of it. So some of this is probably going to feel like it's flying over your head, which is OK. But just think of it as remembering some of these concepts and feature topics so that as you're learning yourself, you can go and remember those and connect the dots on how you can problem solve some of these potential opportunities. So this is a really typical business use case for Cesium I see every single day. This is from the HNTB, which is an engineering firm out of Kansas City. So this is a big public community project where they're connecting two sides of a river with a historical bridge, converting it into a really cool, hip public space with restaurants and lots of hiking trails. And in this picture, Cesium takes up a very small sliver at the very top of it, just covering the horizon. But it's actually incredibly important because for all of these big community projects, you need to tell people what the impact is going to be in their neighborhood. And these projects take a lot of money, a lot of time. There's a lot of pushback from everybody. So making sure that you can show off your physical projects in the correct spots geospatially just paints a way clearer picture for everybody, and there's less time worrying about what it really looks like and how it really impacts line of sight, things like that. Oops, scrolling too fast. Another example of this is from Pannoni, who's here this week. So another engineering firm. I love this example because it's such an elegant, simple scene, but still really powerful. Here they're communicating a new redesigned security barriers underneath the bridge. So they just have one big CAD model for the bridge, a few of their additional CAD models for the barriers, and then they can just put a basic ship asset passing underneath, some cars driving on top, and suddenly it's really come to life. You totally understand what's going on. If you're from the area, you know exactly where it is. And in this case, Cesium takes up 75% of the whole entire screen. So there's no easier way to get that geospatial context than just dropping in the Cesium, going to the Google photorealistic tiles, and poof, you have your scene in the real world. This is GeoPogo. So Michael's here, and he'll be giving a talk this week as well. This is actually a standalone application built on Unreal. And you can pick any location in the world using Cesium. And it's meant to kind of stage your architectural design. So you can import models that you have, or use a library of objects, position them in the world, maybe where the building is actually going to be constructed. And then the goal is to set different camera angles around to create images and create animations of your project. And what you could do, and how it started, was just basically rendering out these screenshots from Unreal Engine. But what they've been doing recently is connecting Unreal to an LLM to generate AI-based animations. So it still uses the ground truth, geographically correct stuff that you'd find in all the Cesium presentations so far, and that you can do yourself. But that's just informing this AI engine to create this really rich photoreal, complex animation that would take so much more time to create any other way. So just to be 100% clear, these pixels are not Unreal Engine pixels, but Unreal Engine here is kind of the ground truth for informing this art style and creating these outputs. So now onto the real presentation. I'm really glad I got Janine to talk about metadata because I was trying to come up with an easy example that was also really compelling, and there's just nothing better than what's in the sample project that you guys have access to from fab.com. So this 3D design tiler is relatively new and super, super powerful. So it used to be primarily just terrain that you could bring in through Cesium, but now any 3D BIM model that you can export as IFC can get tiled up through Cesium Ion and streamed in. The reason that's a really big deal is because Unreal Engine has support for bringing in all sorts of CAD models from all sorts of design softwares, but sometimes they end up being really, really extremely heavy models. You might have to optimize them. You might need to run a bunch of custom tooling and scripting and wait for it to process, and you might need to show off revisions of that project over and over again. So there's some companies out there who rely on this type of streaming technology because you can build just one simple, lightweight Unreal Engine application, and you package it up and send it to the client, and it can just fetch the latest and greatest design data all day long, and it's always up to date. It's always streaming it in, and a lot of the optimization's already being handled for you, which is really fantastic. So if you're in this space, definitely pay attention to the design tiler. I'm not going to go much more in depth on it. You already saw some of the styling capabilities and how all of the metadata is there for you to do with what you want, which is really, really cool. So earlier today, a few minutes ago, you learned how to use some of the CCM tools inside of Unreal Engine to spawn your tile set, have your cartographic polygon, clip out parts of the terrain. And ideally, you loved it so much, you're going to use it on all your projects, and you're going to get really used to doing that. But as you get into more and more production use cases, and you have to do it so many times, you can always be thinking about optimization of your workflow, so automation. And Unreal Engine is totally scriptable. You can script it any number of ways, Python, C++, or editor utilities. So this is dragging out those points of the cartographic polygon one by one. So this is kind of what you guys are about to get into. So you can make a custom shape for your cutouts or your highlights, and this definitely gets the job done, and it is effective and somewhat straightforward. But it can also be tedious to drag out those points and define that custom shape, and then refresh the tile set on and on. So what I realized was that behind the scenes, that core shape of the cartographic polygon is just a spline component, and that is a standard component inside of Unreal Engine. And we have other tools to create and modify splines. So we have a whole entire modeling mode. If you didn't know, there's like 100+ operations for booleans and bevels and extrusions and creating geometry, which is amazing. But there's also a draw spline tool. So if I use that and go to the freehand mode, I can just click and drag on my scene anywhere and basically create the dynamic spline however I want. So here it's extremely detailed spline of an extremely complex shape. I could go and refine it and move the points around if I needed to. And through a magic button click, which I'll show off next, I'm actually taking that spline data and shoving it into the cartographic polygon. And now I have this really complex shape cut out of my environment. So the magic button is a custom right-click menu operation called an actor action utility. And this falls under the umbrella of editor, wow, I really blanked on that, editor scripting utilities, editor utility scripts. And there's multiple different kinds, but basically this kind means that I can click on any object in the scene and make it do anything I want to. And it's completely customizable. And so in this case, I'm not going to expect you to remember or even be able to read the code on the screen, but just to give you an idea of how to approach these kinds of problems and opportunities, this first piece of the code just gets the spline actor that I created through my other tool. It reads every point along the spline and records it into this array of points. And then I just go grab the cartographic polygon, and I delete all the points on its spline, and one by one I just add the points that I already had stored as that variable. And that way I can just incorporate my spline into its spline secretly, even though the CCM people in the room never designed it to read other types of splines like that. So here I'm doing it based off of like a manual spline that I created, but that also means that if you have other spline data that you have, could even be a CSV file of different points on a graph, you can ingest that, turn it into points, stuff it into a cartographic polygon, and get really creative with that. Another similar line of thinking is geometry script. So this is a plugin in Unreal Engine that is really powerful. All those modeling tools I talked about are completely scriptable, every single little function of them. So I'm not going to show off the specific code for this because it definitely gets in the weeds. But using that same exact spline from the cartographic polygon, I can click my magic button and fill it with geometry. So now, if you have a hole in the ground, ideally something needs to go in the ground. And using geometry script, now I have a gigantic flat polygon. Now I could sculpt on it as any other 3D mesh, or I could assign any material I want to it. So it's a really, really flexible way to do that. And you can imagine that now that we're speeding up this workflow with these custom scripts, we could fly around the scene and chop out different neighborhoods, different buildings, and fill them in really quickly, and without having to assign too many new components and create things by hand. So now onto the fun part with materials. Materials are super powerful in Unreal Engine, and I really wanted to show off how you can use them not just for styling metadata like the example does, but how to work with objects that actually don't have any metadata. I got ahead of myself. This is Philadelphia, and it's not too bad on that screen, but what I noticed flying around the Google Earth version of this is that it's really, really blue, and that is a really common problem, and it really sticks out to me anytime someone shows me their project. Because the satellite imagery has been captured through the atmosphere, so depending on the weather, the time of day, the season, whatever, you're going to get different colors in there. So you always have the freedom to change those colors. There is great CCM documentation on how to work with materials. You should duplicate the parent material for the CCM tiles and duplicate the material instances that are being used there, and you can assign them to all of your tiles. There's a really, really clever system put in there for material layers. So all the different effects that you could possibly want on your 3D tiles can be put into these really modular pieces. So the base color, the actual satellite imagery can be a basic, base layer, but then you have your clipping layer and your water layer. You could have the highlight layer, and you could have cartographic polygons talking to each of those layers independently to really layer up these effects. So that's the best way to do it in production. I'm just modifying the base material for speed and comfort, just personally. So when you open up the materials for a CCM, like the one that CCM provides you in the plugin, you have all the material layer attributes on the left-hand side, and those all add up and get combined, and it just connects and outputs to the material attributes on the right-hand side. But you can reach in there and intercept them however you see fit. So we can take the base color from all the CCM tiles and completely replace it, throw it away, or modify it and re-inject it back into the material pipeline. So then in this case, the most simple way to fix these blue Google Earth tiles would be using a tint. So I can just create a color parameter, a vector parameter, multiply it into the base color, and re-hook it up. So you can change your colors however you want on your tiles, tweak it for every possible scenario. So this is the before. We'll see how it looks on this screen. This is the before, and that's the after. So it's a somewhat subtle change, and it's definitely not perfect. I just warmed it up a little bit. It's hard to get perfect just because that lighting is baked into the imagery, and the blue is really baked in there in different levels. The other challenge is every neighborhood and every city and everything could be different. So this is really a case-by-case edit there. And you can go crazy. Any kind of math you want to do or image correction operations you want to do, you can. There's even a material node called color correction, and that includes the color is the input. That includes brightness, contrast, saturation, hue shift, lift, gamma, and gain. So if you want to go nuts on fine-tuning your satellite imagery, you can. This is like the worst possible case. This was Manhattan when I checked last night. that the Google Earth data is split into two completely different captures. So one side is really, really warm, and the one side is really, really cold. So you wouldn't be able to use my method on this one. You'd have to basically make two of those cartographic polygons and adjust the color temperature on this side of the city and adjust the color temperature on this side of the city. World position offset is a really cool material function and capability inside of Unreal Engine, probably other things too. This lets you use the shader logic to actually manipulate vertex positions on the mesh. So like when you're working with the Google photorealistic tiles, it's really baked down. There's no metadata. You can't cache it, save it. You can't extrude buildings taller, shorter. It is what it is. It's really static. But using stuff like world position offset, you can get a lot more creative with how you manipulate that data. So one example that I wanted to play around with and learn from was simulating an earthquake in Unreal Engine. So the first thing I did was establish kind of a height gradient for the buildings because I wanted the earthquake to affect the tops of buildings differently than the bottoms of the buildings. And this effect by itself is already really helpful. You can imagine just assigning a different color there, and then you just get a gradient for your buildings. And you can see that the mountains in the distance are white because they're above the maximum height of the buildings. And this is, I don't know if this is guaranteed to be the perfect shader graph for this, but it worked for my case. That red node on the left is absolute world position. So for every pixel that is rendered on the entire screen, we know exactly the spot in the world that it physically exists in. And so using that data, we can say, oh, this pixel is taller than this pixel. And by setting this maximum height and dividing the pixel height by the maximum height, that's how we get this perfect gradient, 0 to 1, from the bottom to the top of the Earth. Well, on the flat Z for the scene. So this is a separate gradient that I'm creating. This is a texture map that is just pure black and white noise, and it is panning across the Earth left to right on the x-axis. So on the small scale, it just looks like pulsing gray lights, and this is going to be kind of like the earthquake magnitude in that moment. And then that's just in one direction, so I actually duplicated that noise to tile in the other direction. So now it's x and y. And it looks red and green because x and y in the world position is also red and green in the color channels. So those get multiplied into my height gradient, and then I just have a little magnitude parameter that creates this wiggling earthquake effect in my scene. And so this is not physically moving the 3D tile actor. This is moving every single vertex individually. And technically, the mountains are moving at a different offset than the buildings because of that tiling texture map. And the buildings have a little bit of a wobble to them. It doesn't have a true secondary motion swaying back and forth. That would be a little bit more work that I was not prepared for, but it's just to give you an idea of what you can do there. I also made what was the coolest mistake I've ever made, which was flipping the whole surface of the Earth into a concave bowl and creating like a Dyson sphere world. So like the entirety of LA County is thousands of feet above the horizon. This, I really hope somebody takes this idea and runs with it and makes some cool game out of it because it just looks amazing. World position offset, you can also manipulate, move, and rotate vertices. So I didn't fix the artifacty things at the bottom, but I'm just picking up Google Earth tiles and spinning them around wherever I want, which is obviously not the artist's intent there. When moving pixels that much or moving the vertices that much with the material, you run into some issues here and there. One thing I saw on the Cesium tiles was a lot of flickering, so the tiles would just fade in and out. One probable cause of that is the core optimizations under the hood, where the engine says if you're not actively seeing something, we're not going to actively render it. So you can actually turn off this occlusion culling for the entire project, which means it'll always render everything. That's really dangerous. Like, I don't recommend that to be your default, but it would solve all the issues that I ran into with these world position offsets. Because you can imagine if over the horizon is where the tiles physically exist, but then in the shader, after they were created, I'm lifting them up above the horizon. So now if I'm looking upwards, they no longer exist below me, and it's going to get culled out. Okay, so let's talk about piping specific data into materials. So like if I have a 3D object in the scene, I'm moving around and I want that position to get tracked inside a material, that's something we would use inside a material parameter collection. So this is just a list of variables that you can reference in any material anywhere. And it's an asset type that you create inside the Unreal Engine content browser. So this is my box. It's just a blueprint actor, like an empty blueprint actor with one box collision. And then every time the world ticks one frame, or every time the box moves, the box writes to these material parameters. This is the box location, this is the box size, this is the box rotation. And in the material, I actually am collecting that data without directly talking to the box between the material and the box. And there's a material function called box mask 3D. So we typically think of materials as texture maps kind of just projected on UV coordinates. But really, you can get these complex 3D concepts inside of the shaders, which is kind of mind-boggling. So this is that box moving through the world with an opacity mask and clipping through dynamically. So you can scale the box, rotate it. It's not a cartographic polygon, so you can lift it up and it will still reveal things that are underneath it. If this is the only effect you're going for, like the box that clips things out, you should also take a look at the tile excluder, which is a component from Cesium that basically does the same thing. This will give you different flexibility for different use cases, but both are valid. So if we combine those together, we could get kind of one parent shader like this, where a shape cuts out the tiles or excludes everything outside the tiles and creates a little vignette for us. And we can manipulate the colors still. So we can have everything outside of our circle be desaturated and darkened to make sure that the highlight is where we want the highlight to be. And we can also play with that world position offset so that everything that's in the area of interest actually kind of gets magnified like a magnifying glass. So I'm just trying to prime your guys' brains for different creative things you can do with Unreal Engine shaders. Okay, this next topic is cool. I know it can be hard to follow. This is called Runtime Virtual Texturing. So it's a way to bring 3D meshes into the 2D world to get used for materials. So in this case, I have three primitive shapes, a cone, a cube, and a circle, sphere, sorry. And then there's an asset type, an actor type called Runtime Virtual Texture Volume that you bring into the scene, and it's basically just a box. There's a couple other settings I'm glossing over, but we have really good documentation on this feature. But what the box is doing is it's projecting down on the world and writing, it's reading that color data from the world and writing it into a texture map. So the black square is just a texture map to demonstrate to you guys. So it sees the green square, and the blue circle, red circle. What's cool about these runtime virtual texturing outputs and inputs is that we don't have to use the same color as is drawn to the main viewport. So I can tell all the shapes to just draw a white color into that RVT texture. So now we have a black and white mask, and we know how powerful black and white masks are. And any material effect that you can do, you can put into this runtime virtual texture. So you can have this completely kind of alternate universe existing in your scene that is only being read by this one texture map that you can reuse elsewhere. And the other super secret powerful piece of this is that you can tell any of those objects that are writing into this virtual texture map, you can have them be hidden so that it's not rendered to the viewport, but they still exist, and you can still reference them in the texture. So this is a quick example of that orthographic projection happening over a city and being able to scan around like this. It's not particularly helpful, but I just wanted to show what the texture looks like. And it doesn't just work top-down. It actually is an orthographic projection that you can put inside the world and have a beginning point and an end point to write your scene to a texture. There's one downfall here, I think, which is on this style of mesh, it doesn't do a great job of sorting the polygons. So if you have a lot of these overlapping buildings that are technically one object, they'll kind of get crunchy and they'll just mix together in the texture. But it's a very specific issue. And because it's a texture, we can use it anywhere a texture can be used. So in this case, it's basically a mini map in the top right corner. If you are interested in mini maps, there's actually yet another Cesium tutorial about using scene captures for that one. If you haven't caught on, the Cesium team is super good at tutorials, sample projects. Every single function is commented, so thank you, Kevin, Jean, whoever else is doing that. But this is really where I'm getting at, which is any complex shape that can exist in 3D now can exist in the texture map and therefore exist as like a clipping mask. So this 3D object of California, to create this as a cartographic polygon would take a lot of work, or to otherwise try to recreate that in the shader or other methods would be a lot of work. And it's not just a shadow on the ground, in case you didn't see that. That's actually a body of water that's being rendered underneath the Arizona neighborhood. So you can get lots of complex shapes and lots of creative uses out of that. So this is where the real fun kicks in, where I spent a little too much time on my UFO guy. I'm actually spawning spheres underneath the UFO every few steps, and I'm essentially painting the scene with 3D objects. And those objects are going to be hidden to the camera, but they're going to paint into that texture map that I can then project onto the Cesium tiles. So this is Arizona, but our UFO is going to come and use that painted texture map to actually cut down the terrain and cut away parts of the mountain and scorch it. And I spent too much time on that, so we're going to watch it a second time. Oh, thank you. So we can put it to work in the quarry to help, carve out sides of the mountain. But it doesn't have to be purely destructive. We can have it plant like grass alongside the desert river, and any type of thing you want to do to like virtually paint onto your terrain in this way. I think this is a somewhat clever method. So it doesn't have to be UFOs. It could be like a user-driven action of literally drawing onto the landscape, or yeah, I think you get the point. Oops. Okay, so last fun thing I wanted to show you guys was not directly a Cesium feature, and it's definitely not a material feature. But it's a new plugin we have called the Celestial Vault. This is exclusive to 5.6. It's experimental. It's built by the genius Albin Bergeret, who will be here this week. And I think the people in this room like geographically accurate spatial data. So this gives you geographically accurate time of day, but also moon phases, star positions, the deep sky imagery, so you can have the Milky Way out there in the scene. And it's all based on real data, but you can actually replace it all with completely fictional data, create your own constellations. It's a really cool system. So you can go anywhere on Earth with your Cesium tools that you are already familiar with, but you can slide this time of day, and of course the sun will set, but the stars will come out, and the stars are totally accurate. There's literally hundreds of thousands of these, depending on what magnitude you want. The moon phase is accurate. The moon is rotated the right way with the crescent. Super cool stuff. So I immediately thought about astrophotography and doing that in Unreal Engine. So what's great about combining this with Cesium is that you can travel to all these really rare, hard to get to places and test out your ideas of what would be the best position to capture like some nighttime photography. And yeah, you can pick any day, any time, just like that Julian calendar that was talked about earlier. And yeah, in this case, this was rendered out with the movie render queue. And I just told this, the sun system moves automatically at real time. And I just told it, hey, the whole day is going to take 30 seconds. So it just goes and spins the world around. And then another aspect of this would be long exposure photography. So when you're rendering content with Unreal Engine, you can tell it to accumulate samples. So here it's a one frame split second render, but I've rotated the whole sky in an astronomically correct way and let it expose on that 90-degree angle. So that was in Brazil, looking at the southern pole, and this is in Egypt, looking at the North Pole. So just really fun experiment. There's so many things you can do with Cesium beyond just the basics of putting one piece of data on top of another. You can mix and match and get creative and really spice it up with all these different Unreal Engine tools. So thanks a lot for being with me and staying along and having me, most of all.